the housing price prediction in selected areas of Lagos State, Nigeria. So the aim of this project, what's our problem statement? What we want to achieve for this project is we tend to make we want to make customer experience in getting house estimates very, very awesome for them. So what we try to do or what we want to achieve is because there's always this hassle and problem of going from website to website, trying to get the right price for a particular house or maybe for a rent. So to actually help our customers, to help prevent the stress of going around website, what this project is trying to achieve is, okay, you come to, if our model is used for our website, you just need to come there, put in the details of the houses you want, the house details of the house you need. Our model has this ability of giving you the estimate of the house. And for this particular project, we actually limited the scope at the moment to see if our model will work. So we concentrated in Lagos State, and particularly in Lagos State, we are working in Lekki, Aja, Surulere, Ikeja, Yaba, and Ikoyi. We want to test our model over these areas to see if it works. And then one of the reasons why we actually chose this area because they already have a standard, let's say standardized data on the prices of houses in this area as compared to some other areas that are actually not standardized. So at the end of this project, our model, as explained already, will be able to give the estimates of the prices of houses. Once this customer gives us the number of bedrooms, the number of toilets, key amenities like, okay, do you want a gym? Do you want pool? Do you want to good security in the housing? By the time this customer gives us all this detail and the particular area you're looking for this house, our model will be able to give the prediction or sorry, the estimate of the kind of the price of houses you get in that area. And okay, because this is our team for project one, we actually I would like to introduce the team member and the task that has been assigned to each and every one of us. So for the web scraping, getting of this data, it was actually done by me. For data cleaning, it was myself and Joseph that was responsible for data cleaning. Therefore, the exploratory data analysis of the data that we've gotten, it was done by Ayodele Arimide. Data visualization was done by Joseph and Emmanuel. Model buildings to be carried out by Victor and Ayo. Then the model deployment by myself and Emmanuel. So at the moment, we've been able to do our web scraping, our data cleaning, our EDA, and also data visualization. We are currently working on the model, and once our model is gotten, we will deploy it. Then for this particular project, what are the resources that we actually use? For our data source, we used Property Pro NG website. So to get our data, we went there to scrape data. So we didn't actually just choose this Property Pro. We chose it because it has pretty much good amount of data. It was well structured as compared to the other websites that we tried searching for. For the visualization, we used Power BI and Tableau. For EDA, we used Python and Jupyter Notebook for the code and doing the analysis. Then for building our model, what we intend doing is using a sorry, I think there's a mistake here. It's not supposed to be a classification model. I was the one I made the mistake while writing. It's supposed to be a regression model because we are dealing with numbers. Really sorry about that. So for the model, we are going to either use a random forest, a decision tree, all depends on the model we end up choosing will all depend on the accuracy of the model and the ease of explanation. We actually don't want to use a model that will be pretty very difficult to explain, even to maybe the stakeholders that would tend to use our model. Then for the model deployment, we are planning on using Streamlit or Plot Dash, and the choice of this deployment model will also be based on let's say, the easiness to use this deployment tool, and our ability to learn it quite easily will play a big factor in our choice of deployment. Also, for our EDA process, before I call in our EDA, the guy that will explain the EDA process, there were important questions we asked and we wish to answer with our data. And those important questions were, okay, what features are actually correlating with our prices? Because we don't want to just use random features. We don't want to just look for features that has no correlation or not. So we want to even find out, yes, this correlation, these features that we've got, is there any correlation whatsoever with the price of the house? Because correlation is quite important to actually predict these prices. The next question we ask ourselves, what feature has the most correlation? This is also an important question we wish to know. What is the relationship between the price and location? Now, we really don't know. So we're asking ourselves this question, okay, with this data given to us, is there any relationship whatsoever between these various locations? And remember our locations we're talking about, yes, either Lekki, Aja, Surulere, Yaba, and the other one. Is there any correlation whatsoever? Is there any price difference? Does the location play any factor at all in the prices of the house you get in that area? Then we also asked which location is the most, where do you tend to see the most expensive houses? Is there a particular location where, okay, yes, you know for sure that if you're looking for expensive houses, you go to this particular location? And also, is there a particular region that you go to that you tend to see the cheapest area, the cheapest houses? So all these, sorry, all these questions, we want to answer them. Then the last question we posed to ourselves was, what's the relationship between the price and the bedroom size? We want to know, is it just random, or particularly, is there really a relationship between the amount of the bedroom size and the the price? But before I call on Joseph to do the visualization, I would like to show a little bit of the scripting code that we used to get our data. Let's note want to actually show you that yes, we didn't just get this data from some random place or some data was given to us. We actually wrote a Python code that actually we used to scrape this data. So I'll be sharing that screen right away. You share. You. Sorry. Hello, please. Hope people are still.
Yes, we can still hear you.
Okay,
Yes.
okay. Please hold on. Let me switch to. How will I take this thing off now? Please, how do I hide this tab such that I'll be able to move?
You can move it. You can drag it from like the
Okay.
bottom of your screen.
Okay. Thank you. Okay, yeah. So please, can you see my screen? Can you see this code?
Yes, we can.
Yes.
Okay. So actually, yeah, this is the code. We started for this scraping. We actually used request HTML. Now you might actually ask me, okay, why didn't we use the beautiful soup? The reason why we didn't use beautiful soup was the website where we scraped this data from was actually it generates the data using JavaScript, and using beautiful soup would have been pretty hard for us to get it, because when you use the beautiful soup, it doesn't get the data itself. So by the time we actually went to after we discovered this was not working, we had to do some kind of research to know okay, which other Python library would be easy for us to scrape the data. So I stumbled on the request HTML, and it was quite easy. The request HTML library was really very easy for me to scrape the data. So I used the request HTML and also CSV. I imported CSV to store the data that I got from it. Now this is the data, the code that I used particularly to get the data. So this line of code here, this from 33 to 35 is used to store the data that we've gotten into the CSV file, while from 37 down to 64 actually does the scraping itself. So from code 37 down to 64 is for the scraping, while from 33 down to 35 is to store whatever data that's been gotten into the CSV file. And during the course of the scraping, what we did was we actually it was an iterative process, such that once you put your link, like for example, this particular link that you can see right now is for Ikoyi, and once we scrape from page 343, this is just an example. So for a new user that wants to use our code, what you just need to do is, if you want to scrape for example, from page 1 to 50, for example, you just place 1 to 51 down here. The code will do a loop from page 1 to 50 and scrape the data from there. So please, okay, that's the what's the name? This is the code for our scraping. So I think I'll return back to our, I'll return back to this. I think please, maybe at the end of the presentation you could ask questions, whatever question you have on whatever I've said. So I think at this point in time, I will call on Joseph to share his screen on the visualization, and also after it's done, then Ayo does the explanation on EDA. So thank you very much. That's the end of my part. So, Joseph, please, can you go now?
Okay, yes, you can stop sharing, please.
Okay. Yeah, I'm done sharing. You can share screen now.
Okay, can you see my screen and hear me, please?
Yeah, we can.
Okay, great, thank you. So, like Achebe said, trying to know the price of a house in Lagos is usually a big issue for users. So we decided to check some variables, some features, like we mentioned in our questions that we're asking. So we wanted to see if the property type affects the price, and we plotted this right here. So we have houses ranging from maisonette house down to self-contained. And we saw that maisonette houses have a higher average price than self-contained, and the trend is very clear there. Now, areas as well, we made a plot here of areas against average price. And we discovered that one of the questions that we wanted to answer, that we asked in the presentation, the answer is here. Ikoyi has the highest average price for houses. Ikoyi has a far higher average price for houses than any other area among the selected ones. So you can see that Ikoyi's average price is about 8.99 million. Meanwhile, an area like Ikorodu has the lowest average price of houses with about 2.7 million. So from this, a user will know that if his budget or her budget is below a particular threshold, he knows that, okay, Ikoyi is not for me and Ikorodu is for me. And also for our model, as we are working on our model, we know that the area is a very big feature, it's a very important feature that we must pay huge attention to. Area, property type, they are very large indicators. So this particular visualization here, we are trying to see that particular area, the area feature that we picked out from the previous slide. We decided to look at it more in depth. We wanted to see what exactly is happening in that area feature. And we discovered, because we tried to use the area, to explain the price. Try to use area to explain the price. And we discovered that actually, whenever the area is Ikoyi, we discovered that the average price increases by about 8 million. So that means houses in Ikoyi are about 8 million more expensive than an average house in those selected areas in Lagos. Following behind is Lekki. When we try to see what parts of area, what values of area influence the price to decrease, we see that Ikorodu is the biggest boy there. Ikorodu is the biggest determinant there. Once you want your price to decrease and you want to use area to do that, just move to Ikorodu, pick a house in Ikorodu, and your price is driven down. Followed by Yaba. Now, aside area, we know that some other factors also affect the price. So we wanted to see which factors should we check, which factors should we place more attention to, should we rather place more attention on as we are building our model, as we are checking other things around it and trying to solve this problem that we're trying to solve. And we try to add the gym, we try to add the pool, we try to add CCTV bed, all the features that we have in our data set. And we discovered that what influences price to increase most among all of them is when the property type is a maisonette house, which is a value in the feature property type. About 9 million naira increase happens when the property type is a maisonette house. So since we already established that property type is a very big determinant, we have written this down and we have noted it, and it will help us in our model building. Now, when gym is true, that means when there's a gym, it also has a very, very, very huge effect, about 8 million naira increase above the average price. We can see this line. Can we see this dotted line here? This blue dotted line here. What it says is that this is the average of the average price of houses. That means that when we sum all the prices of the houses and we divide, so the average price of the house in those areas in Lagos is about, give or take, how many million? Give or take 2.5 million, give or take 2.5 million. Okay, yes, 2.03 million. Now, whenever there is a gym in the house, the price skyrockets by as much as 7.74 million. The pool, having a pool in the house also has a very big effect as well. Having a CCTV in the house also has a very big effect. Having more than 4 beds in the house has an appreciable effect as well. And having a BQ also has some effects. So we have identified these features and we have seen how they affect the price. Now, moving here, we thought number of bedrooms seems to be a very important feature. So we wanted to see, since we know that area affects price, we wanted to see if the number of beds on average has a correlation with area. We wanted to just explore that. And we checked and we discovered that, first of all, this is a waterfall chart here. This one is a waterfall chart here. And we discovered something. We discovered that now, like we checked earlier, Ikoyi has a very, very, very large average price. And we see that, okay, it's increasing that way and there is less and less as we move down to Ikorodu. Now, when we check average of the number of beds, we discover that it is almost the same trend, even though it is less profound in the average number of beds. That means that average number of beds has quite a correlation with area, but it's not really giving us a very, very strong relationship that we can really pin on price based on association with area. This particular visualization, we wanted to check the direct effect of number of beds on average price, and we saw that, like we predicted, or rather like we tried to decipher from this visualization, we saw that it's not really a linear relationship. We saw the graph moving up and the graph started tumbling down at a point. We discovered that we can't really trust this feature called number of beds, but we should check it out, but we shouldn't really place so much emphasis on it like that. Now, we found a house that is self-contained during the EDA, after the whole cleaning, that had 10 bedrooms, and that house was said to be a self-contained building. Now, if you are staying in Nigeria, you will know that a self-contained building usually has just one room. So our approach was to treat that particular value as a data entry error, because a self-contained should have just one room normally, and if we're having 10 there, then it most probably means that the person that was entering data wanted to actually put the value of 1 instead. So also, you know, we checked and we saw that pool, having a swimming pool in the house, is a very big determinant, and we just wanted to see exactly how much. Now we plotted the average price against against the presence of a pool, whether there's a pool there, true, or whether there's no pool there, false. And we saw that, in fact, it is very glaring. And once there's a pool, the average price is about 9 million naira. Meanwhile, once there's no pool, the average price is about 1.5 million. So that is a very clear indicator of what we have seen so far.